Hi, today we're going to consider infinite limits and vertical asymptotes. There is an association between them. Let me remind you, a function y equals f of x is a vertical asymptote at x equal a if the limit as x approaches a from the left of f of x is plus or minus infinity, or the limit as x approaches a from the right of f of x is plus or minus infinity. My function blows up. That's how I usually say it. This is not a technical aspect in terms of a limit. Technically, the limit does not exist because it is not a real number. However, this is explaining how it doesn't exist. It doesn't exist because my function gets extremely large, infinitely large, or infinitely large positive or infinitely large negative. We don't say it gets small, we say it gets large positive or large negative. So, let's look at some examples. My first example is example 1C from the worked out homework problems, and it is in the infinite limit section. Limit x approaches 2 of x squared minus x minus 9 over 2x minus 7 times the natural log of x minus 1. Now, first off, when do we get an infinite limit? This is different than an indeterminate limit. Notice in this particular situation, as x approaches 2, my denominator is still approaching 0. The natural log of 1 is 0. So the denominator is approaching 0. However, my numerator is not approaching 0. My numerator is approaching 4 minus 2, which is 2, minus 9 is negative 7. When this occurs, the denominator approaches 0, the numerator does not, we are guaranteed to get an infinite limit. The question now becomes, which infinity? So, in order to determine that, we need to consider each side. This is also another example of one-sided limits. So, the limit as x approaches 2 from the left. So, let me write. In this particular situation, whether we're approaching 2 from the left or from the right, my numerator is approaching negative 7. The first term in my denominator is approaching negative 3. The second factor, sorry, not term factor, the second factor in the denominator is approaching 0. But it depends on which side of 0 we are approaching. Since x is approaching 2 from the left, that means x is smaller than 2, which means x minus 1 is smaller than 1. The natural log in this case is negative. It's approaching 0 from the negative side. Overall, I usually write this in this form. This is notational. I mean 0 from the negative side. So overall, I have 3 negatives multiplied together, which means the overall fraction is negative, hence it approaches negative infinity. When I consider the limit as x approaches 2 from the right, same function. And natural log of x minus 1. My numerator is still approaching negative 7. That doesn't change. The first factor is still approaching -3. That doesn't change. My second factor now is approaching 0, but from the positive side. Because x is bigger than 2, x minus 1 is bigger than 1, the natural log of that is positive. Overall, then, I now have two negatives multiplied together, which means we end up with positive infinity. Since these are not approaching the same infinity, just like the situation with one-sided limits, the limit does not exist. Okay? My second example here, let me erase this. Second example, a little bit simpler in some respect. Limit as x approaches 3 from the left of 2x minus 7 over x squared minus x minus 6. Again, notice my numerator is not approaching 0. My denominator is approaching 0. This is going to be an infinite limit. To determine which infinity we're approaching, I will go ahead and factor like I would have before. X minus 3, x plus 2. Again, my numerator now is approaching -1. The first factor is approaching 0, but from the negative side, because x is less than 3. My second factor is approaching 5. Overall, I've got two negatives multiplied together, which means a positive infinity. And that would be how we would write this limit. I want to look at now vertical asymptotes. And with vertical asymptotes, if we want to determine where vertical asymptotes occur, what we need to know is my denominator must approach 0. My numerator does not approach 0. So, again, I'm going to do two examples. Suppose f of x is equal to 3 over 4 sine x cosine x minus the square root of 3. In this case, obviously, my numerator is never going to be 0, so it doesn't matter what I put in for x. So really all we need to do is determine where the denominator, or when the denominator approaches 0. My vertical asymptotes are going to be when 4 sine x cosine of x minus the square root of 3 is equal to 0. We have to solve this equation. Now, to do this, we need a trig identity. Hopefully you recognize 4 sine x cosine of x is 2 times 2 sine x cosine of x, and therefore this is 2 sine 2x. I will set that equal to the square root of 3, which means the sine of 2x has to equal the square root of 3 over 2. Therefore, 2x would equal, sine is positive in the first and second quadrants. This would be pi over 3 plus 2n pi. This is all the times that it occurs in the first quadrant. And sine is also positive in the second quadrant. So 2x is equal to 2 pi over 3 plus 2n pi. N here represents an integer. Any integer we want. Therefore, my final values are x equals pi over 6 plus n pi, or x is equal to pi over 3 plus n pi. These are all your vertical asymptotes. My last example, by the way, this example I should have mentioned is problem 2a in the homework section worked out for the vertical asymptote section. My last example is going to be g of x is equal to x squared plus x minus 6 over 2x squared minus x minus 6. Again, I need my denominator approaching 0, my numerator not. So, in order to determine where the denominator approaches 0, the first thing I will do is factor my denominator. Generally, we need to know where it's equal to 0. In this case, it factors nicely. If you want, you can solve. If you don't want to factor it, you can solve using the quadratic formula. But as I say, in this case, hopefully you recognize that this factors nicely as x minus 2 times 2x plus 3. So I'm going to go over here and actually factor it. Now, this does not mean that I have vertical asymptotes at x equal 2 and x equals negative 3 halves, because in this case, my numerator also factors with an x minus 2 factor. And so this reduces to x plus 3 over 2x plus 3 as long as x is not equal to 2. Which means, where do I have the denominator approaching 0 but the numerator is not? My vertical asymptote is only when 2x plus 3 equals 0 or x equal negative 3 halves. That's the only vertical asymptote. X equals 2 is not a vertical asymptote.